Okay, hello everyone. Welcome to the Unit 3 test, test 1 study guide. Yes, this is a very thick study guide. We're going to go through it. Not that many questions, but graphs take up a lot of space, so it has a lot of pages. So let's start without a calculator. Find the values of these trig functions below. Usually if this happens, this is always going to be some um, special angle on the unit circle. So here I have sine of pi over 3. We go to our fancy unit circle, find pi over 3. Sine is the y value, so this should be root 3 over 2. Next up, we have cosine of 5 pi over 6. We find 5 pi over 6. Cosine is the x value. That is negative root 3 over 2. So I do negative root 3 over 2. Finally is tangent of 7 pi over 4. We find tangent of 7 pi over 4 is down here. Tangent is sine divided by cosine. So we would write negative root 2 over 2 divided by root 2 over 2. 2's cancel out, root 2's cancel out. That leaves just a negative and a 1 right there. Make sure you write the equation from time to time. Write this fraction, even though it's going to be really easy. Sometimes you don't mess up with the undefined versions of these. Next up is going to be sine of 330 degrees. Find 330. Sine is the y value, negative 1/2. Cosine of 270, find 270. Cosine is the x value, so that should be 0. And then tangent of 300, well, that is y divided by x, so we have negative root 3 over 2 over 1/2. Keep change flip if you want to do it that way, that is fine as well. Negative root 3 over 2, change this to multiplication. Flip the bottom fraction to be 2 over 1. 2's cancel out, leaving a negative root 3 multiplication, negative root 3 over 1, which is just negative root 3. There we go. Okay. Give me 1 second. I'm going to switch out writing utensils here. This one seems to be running out of ink. Okay, so let's keep going. In the xy plane, two different angles, alpha and beta, are in standard position and share a terminal ray. Based on this information, which of the following is possible? So, put away our unit circle for now. Which of the following are possible? So what this is saying is that we can draw it out real quick. We have two different angles, alpha and beta, and they are in standard position. So let's draw one angle first. We'll call this alpha. And so there is our angle alpha. And beta. And they are in standard position, and they share a terminal ray. And so when we draw beta, the only thing that has to be true is that they share a terminal ray. So beta might look something like this, as long as we stop back at that same terminal ray. So this one right here is alpha, and that blue one is beta. See, there should be a light on this. My hand shadow is, there it goes. So if they share a terminal ray, this is what you really should be focused at here. Shared terminal ray. This means that they are coterminal. They have the same terminal ray, which means that they have to be, in number of full rotations away from each other. So pretty much, since all of these are in radians, we need to find which one of these is a multiple of 2 pi. Which of these is a multiple of 2 pi? So let's see here. We want to the difference. The difference is, let's put diff here. So if I do negative pi over 4, so A, subtract these, negative pi over 4 minus negative 7 pi over 4. Well, that's going to be, changes that to addition. So that's going to give us positive 6 minus 1. So that should give us 5 pi over 4. So it's definitely not A. If I subtract these two here, 3 pi over 5 minus a negative 3 pi over 5. So we'll change both those to positive now, and that would become 6 pi over 5. It can't be B. Here I have 2 pi over 3 minus 8 pi over 3. This is going to give us negative 6 pi over 3, which comes out to negative 2 pi. So this one is a multiple of 2 pi. 2 pi times negative 1, that counts. So it's probably C, but let's just make sure, and we'll subtract these two. 5 pi over 6 minus pi over 6. That's going to come out to be negative 6 pi over 6, which is just pi, so it can't be D. C must be our answer. So coterminal, subtract the two angles and see if they are a multiple of 2 pi apart. Here I have, let f be a sinusoidal function. The graph f of x is given in the xy plane. What is the period of f? Now this, again, this is a very dense question mathematically. Pretty much sinusoidal function. That means all you gotta know, it's a wave. It's some wave. And we have a graph of it, and it's on the xy plane. It's on the coordinate plane. What is the period of f? Well, the period is how long it takes for the graph to repeat. One way to do that is find two global maxes and find the difference between these two. So this point right here is what? That is 5, 3. This point is 1, 3. What is the distance between these 2 points? Well, 5 minus 1 is equal to 4. Should be 4. We're going to skip number 3 for now. We'll come back to it probably on Tuesday. That's just some calculator stuff for regression. What's going to tell you, this is for calculator, but the big thing right here, so the average monthly high temperature, yada yada yada. Again, we'll talk about this later. You want a sinusoidal regression. That regression should tip you off that you have to do some calculator stuff. This isn't something you can do by hand, but we'll come back and talk about that on Tuesday. Let's do number 4. A certain type of machine produces a number of amps of electricity that follows a cyclic, periodically increasing and decreasing pattern. The machine produces a maximum of 7 at certain times and a minimum of 2 at other times. It takes 5 minutes for one cycle, from 7 to the next 7. Which of the following graphs models the amps? So, important stuff here. I have a max of 7. I have a minimum of 2. So, I mean that, and then I have 5 minutes for one cycle. So let's see here, which one of these graphs fits this description here. If we have more than one, we'll figure out some more things we know about this. So max of 7, minimum of 2. So 7, 2, 7, 2, 7, 2, 7, 2. Okay, so all of these have a max and min of 7, 2. 5 minutes for one cycle, so that is the period. So from here to here, that's from 6 to 1. That is in minutes, so that is 5 minutes. This one is probably it. Let's make sure. So there is a max. I don't have another max over here, but I do have a minimum. From the max to the min is 5 minutes, so the period here is twice that. So the period should be 10 minutes. So it's not this one. This one is from 0 to 2, so this has a period of 2, so it can't be that one. This one has a period of from 5 to 1, so 4, so it can't be that one. It must be A. Okay, next page. Okay, a lot of stuff going on here. The figure shows a robotic arm rotating in a circular counterclockwise direction that completes one rotation every 2 seconds. So one lap is every 2 seconds. So we can draw on here, going around takes 2 seconds. Point S, so this point here is at the tip of the arm, and point X does not move. Okay, so this is the one that moves, this point is stationary. As the arm rotates at a constant speed, the height of S of X is measured. So this right here is our Y value. Whatever the height here is our Y value. And so we're not measuring from the base of the table, we're measuring from this line right here. So, okay. At its lowest point, 6 inches directly below X. So right here, that's 6 inches. So this is the minimum. And this is the max, is 20. According to this, at its highest point, S is 20 inches directly above X. And this is below X. Okay. The sine function of h models the height of S above X in inches as a function of time in seconds. A positive value of h of t indicates S is above X, so positive is above, negative is below. And then, so here, part A. So that's just the description. That's just the description of what is happening. The graph of h and its dashed midline for 2 full cycles is shown. 5 points F, G, J, K are labeled in the graph, no scale is indicated, and no axes are present. Determine possible coordinates T, H, T, so we can find the x, y values for these 5 points. Okay, so we don't have any x-axis, we don't have any y-axis. All we have is this stuff right here. So let's see. What can we figure out? So I know this line right here, this max has to be 20, this max has to be -6. The middle, this midline is going to be y equals, and we want to find, oh, I'm off the screen here. So this max is 20, this is the minimum 6, this midline is going to be the average of these two. So it's going to be 20 plus -6 over 2, which is going to be 20 plus -6 is 14 over 2, which is 7. So the midline is 7 inches above. If you want to mark that on here, you can. So like this point right here, the center of this circle is 7 inches above X. 7 inches above X. So that should give us some points here, or at least some parts of some points, at least some Y values. So F, this has to be some value 20. P is going to be the same thing. Some value in 20. This part right here is going to be some value and -6. And this part right here is going to be some value and +7. And this point right here is going to be some value, some value and what is this? Some value and +7 again. Okay. Now what about, so y values are easy. We got all those y values knocked out. Now we need some x values. I don't see anything that says where it would start. Lowest point. Oh, at time 0. At time 0, S is at its lowest point. So that is important. At t equals 0, S is at its lowest point. S is at its lowest point. So I'm assuming it just lets us, we can just go from that. So if we mark this, we can say J right here. This is a low point. We could say that this is 0. Now, if this is 0, this is half a rotation. And the period is, what's our period? 2 seconds, right? So half a rotation, so this should be 1 second, since this is half rotation. This is a full rotation, so it should be 2 seconds before. It'll be right here at -1. And then this is halfway between those, is we're essentially quartering this thing. And so this should be -0.5, and this could be 0.5. There we go. There are some possible values for F, G, J, K, and P. Part B. The function h can be written as a cosine of b, t plus c, that time thing. Find the values of constants a, b, c, and d. So we need to find a, b, c, and d. So since a right here, a is amplitude, and our amplitude is 20 minus -6 over 2. So our amplitude is 13. And since this is starting at a bottom, we want it to be a -13. So we'll say a is equal to -13. B is 2 pi over the period. So the period is 2 seconds. So B should be pi. 2 pi over 2 is just pi. C, we could set C, since we're starting at negative cosine. This tells us we're using cosine, and we want to make it negative, so we'll make our A negative. Our C should be 0, because there should be no phase shift. That is the exact starting point, so we should be good there. And our D is going to be whatever the midline is, which is 7. So there's our A, B, C, and D. And then finally, part C. On the interval t1 to t2, refer to the graph in H as in part A. The t coordinates of K, so K is t1, so this is t1. And the t coordinates of P right here is t2. On the interval t1 to t2, so that tells us on the interval of t1 to t2, so in between here, this is our interval from here to here. In that area right there, which of the following is true about H? H is positive, so it's all asking about positive, negative, and increasing and decreasing. Well, K is already positive. K is 7, which is a positive value. And it goes up to 20, so it should be positive the entire way. Either should never goes negative in that, so it should be positive. That cancels out C and D. And because we're going up the entire time, it should be increasing, so it should be A. And then finally, describe how the rate of change of H is changing. So rate of change is changing. That is concavity. That rate of change of rate of change is concavity. And this is concave down. If you see it right here on this interval, this is concave down. So which tells us that the rate of change is decreasing. The rate of change is decreasing. Okay, I'm going to cut this video off here, and I will see you guys in the next video.